you have to implement it that way. It's just that you'll see one really effective. A lot of our job is to use an effective language. How do I create an effective language for querying? We're going to see that. And in the process of seeing the language evolve, it's going to be really clear how you implement it. I'm not going to implement it for you, but it'll be really clear. Okay? And you can ask questions as we go on. How would you implement that, Prof? Okay, and I'll tell you a little bit. I won't tell you every last little widget, but you know. So if you can come, do come. If for some reason you can't come to the Friday morning help session, in my open office hour on Tuesday, I can talk a little bit, you know, as long as there aren't too many of you, I can, you know, enough to fit in my office, I can talk about it. So don't not come just because you say, oh, well, I'll come to his office hours, because if 30 people show up, only 5 will hear the conversation, okay, because that's all I have room for in my office. But so strongly recommended that you come, and strongly recommended, of course, that you come to class on Tuesday. I will, if we can, I'll be putting up videos, but no promises. You know, even with NAG's expert help, they may or may not work well, so we'll see. But I think it may. Okay, so let's begin. I've labeled this lecture and the things we're going to look at as abstract data types. There may be a better name. There's an equivalent name called value types. And I ran out of time, didn't have the time to do it, but I meant to change that title to value types. And everywhere I mentioned it in the presentation, instead of saying abstract data type, to say value type. Value type is a type that can be copied and assigned into unique objects, not the C# Java handle copies that gives 2 handles pointing to the same instance, but copying the instances themselves. We're going to see exactly how to do that today, among other things. We're going to see how to do quite a few things. And when we're done on Tuesday, you will know how to design a class. End of story, you will know everything useful to know about designing a class. Now, you know, we're not going to talk about inheritance. We're not going to talk about compound objects. All of that will come later on. I don't promise you'll have all that, but you will know how to design a single class. These are recipes. The slides you're going to see today, each one of them is a recipe for how you do. You won't do it exactly like that, but it shows you very clearly the idea. So let's get started. Oh, by the way, you know, when you come to the help session, I think you should plan on coming to the 9 o'clock, because if everybody says, oh, there's going to be 2 sessions, and everybody shows up at 10:30, not everybody will fit, and some will never get in, period. Because if you're not sitting in a pink seat, you're out of here. You can't bring in seats from another room. Okay, don't do that. Don't do that. Okay, imagine Arnold Schwarzenegger with his pump shotgun saying, don't do that. Okay, so I'm not the Terminator, but sometimes I like to pretend I am. But anyway, my daughter teaches Spanish in high school in Central Illinois, and she was in the Army, and she tells her class, I know 5 ways to kill you with my pinky. To keep her class in line. And a lot of us are like, do you really? So, anyway, you know, come at 9, and then if it's full, just, you know, work on project 1 down in the, you know, the atrium area, and come back up at 10:30. All right. Now, I have a student had said, you know, in Piazza, hey, you're going too fast. I don't understand half of what you're talking about. There's too many links. I don't know what you clicked on. So A, I'm trying to go a little slower, and B, I am highlighting every link that I click on. Probably today I'm only going to click on that one link. But my goal is to have every lecture page, the highlights are what I've clicked on. Now, you know, there's menu up here that we'll occasionally look at, notes and stuff, and there's no good way for me to highlight them. Okay, but there is, but I ain't going to do it because it's too much work. But I will do this. So, abstract data types. So think value types. C++ was built from the ground up to support making value types. That's what makes it what it is. That's why it isn't C# and it isn't Java, because it's built to create value types. And you can create them and you can put them wherever you want. You can put them on the native heap, you can put them in stack memory, you can put them in static memory, wherever you want. Okay. So there's you know, some words about data abstraction. I'm going to skip over them. You know, you read them, but classes, here's what we want from a value type. We want, so constructors should allocate all of the resources a class needs, either constructors or some member function. The class member function should allocate any resources it needs, and the destructor returns all of the allocated resources. End of story. No other way. Don't do it any other way. And for that reason, users don't have to participate in that resource management. They just create an integer class, use it when it goes out of scope, all the resources are returned. Really nice. They don't have to call dispose or any of that monkey business. Okay. So. So we want construction and destruction to manage the resources, and the scope-based scope-based resource management is very elegant. We declare, we create the resources needed, we create an instance of the class with all its resources somewhere in some scope, and when it goes out of that scope, it's all returned automatically. You don't do anything, just gone. We want to be able to create arrays of our value types, and that has some interesting implications. So to store something in an array, every instance of the class has to have the same size, because that's what an array is. Size, 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 size. It's not a list. Okay, it's not a map. And I claim that you can store a string that has 2 characters and a string that has 50,000 characters in the same array, because they have the same size. And you say, how could that be? Okay. We will address that very issue. There's seats right here, guys. Yep. If we run out of seats, I'm going to holler at people, because that means there's people from the 8 o'clock session here. Okay, so we need to be able to pass to functions, and we want to be able to pass by value and by reference. When we pass by value, that means we're making a copy. We make a copy of the object, a valid, unique, separate, disconnected from the source copy in the stack frame of the function. Pass by value, or you return by value, you're getting a copy. There are some exceptions to that, which we'll talk about this morning, some sensible exceptions, so just hang on. We need to be able to observe and modify state. I'm not highlighting here very well. Let's see, I have a pointer here. Why don't I use the pointer? So, yeah, give me a highlighter. So where's my highlighter? Where did it go? Oh, it's hiding it from me. Isn't that nice? So give me a ink color. Give me some nice dark color. Okay. So observing and modifying. That. Forget the pen. Okay. how do I get, let's move to a laser pointer. Okay, good. So I don't know how you erase that. So I just go, oh, still there. So until I delete it, it's going to stay there. But this says, I can't even read it. This says, provide access or mutator functions. Assignment of objects. We want to be able to make assignments of one object to another. And this isn't a handle assignment. When you assign handles, as in C# and Java, you got two handles pointing to the same underlying object. Our goal is to have two unique objects. So if I have handles, each pointing to a unique object, and I assign this guy to that guy, okay, then what I expect to happen is all this guy's state get copied over into that guy's state. And we'll see exactly how that happens. We want to be able to coerce objects, and what that means is that so I am going to use a string class as the demo. I don't want you to use this string class. I wrote this string class back in the distant mists of time before the standard library had a string class. There was a time when the standard library didn't have a string class, and I wrote this one, and I like this one better than the standard string. But I never use the standard string. I'm sorry, I never use the string class. I never use the Jim Foster string. Why? Because everybody knows what the standard string class does. Only you and I know what the Jim Foster string class does. So I don't use it. And you shouldn't. But it makes a really nice teaching tool because we all know how a string ought to behave. We got this nice mental model so we can focus on the mechanics of how that behavior happens instead of sitting there trying to understand what's going on. We know what's going to go on, we just have to figure out how we make that happen. So that's our job today and Tuesday. Coercion of objects says I am taking an object of some other type and turning it into an instance of this class. So for example, the string class, I might want to construct a string from a literal string. A quoted string, okay? Very sensible thing to do. I may want to coerce the other way. I want to take one of my strings and send out a literal string. Maybe I've got a function that expects a literal string. You know, and so the compiler will tell me mismatch unless I give it away to cast that out. And so I'll write a cast operator that will, and what my cast operator does for my string class is it just returns the pointer to my underlying array of characters as a const pointer. So hopefully nobody will use it to walk all over that data. They'll just read from it, okay? You know, you can hack the const and get around that. I'm not going to show you how, but you can, but you don't want to. It's a bad thing to do. And the operator symbolism is really useful. For strings, plus means concatenate. S1 plus S2 means onto the tail of S1, put all the characters from S2. Okay. So the operator symbolism is really nice. You know, all my degrees are EE. I used to work in industry as an electrical engineer. I did a lot of design stuff. And I wrote a lot of computer-aided engineering design software in C. And I was delighted when C++ came out. In 1988 was the first available commercial compiler you could afford. $200, I think, from Zortek. It was a nice compiler. It had this nice operator symbolism, and all of a sudden my algorithms went from this mishmash of called functions, and you couldn't tell what the heck was going on because it didn't look anything like the algorithm on paper. Now with that operator symbolism, the code looks an awful lot like what you write on paper, and that's a big deal. It's a big deal. Makes it easier to understand and perceive and fix stuff. Okay. And so here's the kinds of things we're going to use to do that. So this is a promotion constructor. any function with the name of the class, so this is class X, any function with the name of a class is a constructor. And so this constructor takes a single argument, so I am promoting a T-type instance into an X, promotion constructor. If you Google on that, I think there's probably 2 of us in the United States who use that term to mean that, okay? But it's not widely used, but it's a good descriptive thing. And I write it this way, XX object equals T object, okay? That's what will cause that promotion constructor. There is no assignment here, none. There's just that one call to that constructor. On the midterm, I will find a way to ask a question about that indirectly, so it isn't so obvious what the answer should be about, you know, what does this statement do? And I guarantee you, a third of the class will say construction and then assignment. A third of the class. And they'll lose copious points because I've stressed that it is not that, okay? A third of the class. I've been saying this for the last 15 years. And every year, a third of the class gets it wrong. Don't be in that third, okay? You get it right. Default construction, so I can initialize objects to be default, whatever that means. And that means I can create an array of objects of default objects, okay? Because what happens here is the compiler will generate code to call that function on each element of the array. Okay? And as long as, you know, every instance has the same size and that size never changes, works just fine in an array. And we'll see how that happens.
Why do we need a void constructor for an array when you can just use the promotion constructor?
Because a void constructor says, I just want to create an instance object and I don't have anything that I want to make it look like. Okay? This just says, give me a default value. Whatever your model of default is, that's what I want. Okay? And that's probably the most often called constructor of all construction calls. Okay, a destructor. Destruction calls are usually implicit, so I won't show you. When you call delete, that calls a destructor on an object in the heap, and when your object goes out of scope from a stack frame, the destructor is called then. So almost never do we explicitly write a destruction, write a call to destruction. Pass an object by value. This means I'm copying. I need a copy constructor to do that. I have to copy the object from the user's scope into the scope stack frame for this function. So there's copy going on. And then we need to manipulate the state because we don't want to make our state public so that other people are monkeying around with the state and putting it into absolutely absurd, you know, giving it totally incorrect values. We want the values to be determined only by our member functions. So we need a way to make the state visible and to change it. We need to be able to assign to it. We need to be able to make casts either explicit or implicit. So here, T of T equals T. This is the new old style of casting using parens. This is the old style of casting using parens around the type. This uses parens around the object. They do exactly the same thing most of the time. And this is the modern way of casting. And this will do an implicit cast very often, okay? If we haven't made our cast operator explicit, it'll do an implicit cast. So I have an instance of my X class, and I have another type here, and the compiler says, when it scans it, it says type mismatch, type mismatch. Can I resolve that in a single step? If it can resolve it in a single step by calling my cast operator, it does so. If it can't, it won't, and it fails to compile. Almost never will it take 2 steps. If you can do it by calling 2 separate functions, it'll fail to compile. It's got to happen in one function. Just because the compiler, you know, doesn't want to do a huge, enormous amount of analysis. So here's the C++ memory model. We've talked about that already. We got to remember that because we're going to be using that in the slides that follow. So here comes the string class. Manual page, maintenance page, stuff you should have. And now here's the class declaration. Let's make it a little bigger. So notice that this string class has a pointer to an array of characters that will reside on the heap. And it has an integer len and max. Max describes the capacity to hold characters, and len describes how many characters there actually are. Why would I have two different ones? Why don't I just make them the same, always? Yes?
If you have max, you can allocate the same amount of space for each array.
Yeah, you can, but there's a more important reason. The more important reason is, let's suppose I'm reading out of a socket and I'm appending them to a string. You know, I do that quite frequently. You will do that in Project 3. So if I made max and len identical always, I just use one length measure, then every time I add a character, there's room for it, go and reallocate one more character's worth of memory, copy everything over. Now I add another character, reallocate, copy everything over, reallocate, copy everything, reallocate. So every single character addition forces a reallocation. What my class does and the standard string class does is it allocates some hunk of memory by default. I do 10. I've forgotten what the standard string class does. And then if you run out of space, the class functions silently go away, allocate twice as much memory, and copy the characters over and insert the new character, okay? And if I run out of that space, it doubles it again, so it's going up in binary increments. And so even if I guess very badly the size, you know, I can initialize it. You know, I have a constructor that says use this many, provide this many characters, but even if I badly guess, I won't do that many allocations because it's going up in binary heaps, binary jumps, you know. So 8, 16, 24, you know, 32, pretty soon 256, 1024, gazillion megabytes, whatever, okay. Okay. Now, were I designing this class today, I would not use ints, I would use size underscore t's. When I designed this class, size underscore t didn't exist. And everybody was using ints to index. The standard library was using ints to index. And so to nicely interface with the standard library without getting a bunch of warnings and stuff, I used ints. But today, the standard library uses size underscore t, which is a long int. It's a redefinition of a long int. It's an alias for a long int, okay? And I would use that today. But, you know, I'm not going to go back and change it. As a teaching tool, this is fine. Gives me a chance to say that, okay? So now, I have a constructor that can be a default constructor. I can call this with no arguments, and I get a capacity of 10 characters. But I can specify 5,482 if I want and get much more capacity. This is a copy constructor. Notice the const. So this says, I promise you I won't change the source of the copy when I make this copy. This is a move constructor. And what this does is this steals the resource of the source. So it isn't const. It's going to mangle the source into some perhaps unusable. And the model is, when the compiler will call this is when I am doing what looks like a copy from a temporary. That's what this means. This can be a temporary. And if it's a temporary, then the compiler will call move. If it's not a temporary, then the compiler will call copy. So the fact that it's temporary is I'm stealing that other object's resources, and so it's no longer in a good state, so it darn well better be a temporary, because I shouldn't use it again. So that's the only time the compiler will call it, unless I force it to do something else, and I'll show you how to do that. But this is called a universal reference. It means I can put an R value or an L value. And R values and L values mean close to this. R value is something that occurs on the right hand of an assignment, doesn't have an address. May not. Could be a temporary. L values are things that have to have addresses, because I'm going to store it there. I can't store it there. Temporaries, the compiler just chooses some memory, some of its own, its own memory, and puts it there. Okay. And doesn't tell you where it is. But L values are you declared it, and so that says there's some known place. So this will accept this. Is called a universal reference. Some people call this a universal reference, and that means it will accept either an L value or an R value. Okay. Typically, the compiler, this is really a parsing. The way it's used here is really for parsing. The compiler doesn't want to apply it to anything except an R value. There's no real good way to say this is definitely an R value. There is, but a very complicated way. This ampersand says this could be. Okay, so the compiler is willing to consider applying. But anyway, it's the syntax is telling the compiler this is a move constructor, and if you're willing to trash the source, then use it. And it's only willing, unless you tell it differently, to trash the source if it's a temporary object. If I've created some complicated data structure inside a function, that data structure is going to become invalid as soon as I leave the function. So why worry about it? So I can move that data structure out, steal the resources very effectively, very quickly, and then this guy becomes garbage, but he's going away. He's going to become invalid as soon as I exit the function. So this is a promotion constructor. So here I have a literal string, constant char star, and I've labeled it with the keyword explicit. And this says you can only use it, this will only compile when you explicitly say, I want you to call this constructor. We'll see examples of that in a few minutes. Destructor, assignment operator. So this is copy assignment, this is move assignment. Does something very similar. It's stealing resources from the source. There are two indexers. So this provides an indexing for elements of my class. So if I have an internal array, like my string has an internal array, so I want to be able to access it to get at the 0th or the 5th or the 10th character in that array, that lets me do that. But I have two. And the reason I have two is that one of them returns a reference to a char, and the compiler will not allow me to apply that to a const object, const string. I may only be reading that. I may never try to write to it, but the compiler isn't going to do that analysis. It looks at that one line and says, no, you could change it. It's const, disallowed. If it had to do all that analysis, it would take a month of Sundays to get our programs to compile. I'm exaggerating. I like to exaggerate, but there's some element of truth there. Now I have operator bracket const. This tells the compiler, oh, this is a promise that I am not going to change the string that I'm indexing. Okay. So this promises that I won't change that source. This promises that I won't change the object I'm indexing. And notice I returned a character by reference here, so I could write to that character in my string. I could change the third character from A to Z. But here, I can't. I can change this. I'm returning this by value, and I can change that character all I want, but it won't affect the string in any way, because it's just a copy. It isn't a reference. This string is a holdover from that comment over here. Operator plus equal concatenates a single character on the end of our string, and operator plus equal with a string concatenates a string to the end of our string. And we won't get to those functions today, but we will get to them on Tuesday. Operator plus will add two strings together, and that will generate a temporary. If I say S1 equals S2 plus S3, S2 plus S3 is a temporary, unnamed. And now, when I say assign S1 equals, guess what is going to happen? The move assignment operator is going to be called. It'll trash that temporary, but who cares? It's just a temporary. It's unnamed. I can never get to it. Even if it was valid, I couldn't get to it because it's unnamed. I don't have a name for it. Okay. This is my cast operator. The cast is, aside from constructors, the only function that doesn't have a return value. Void is illegal. It has no, in a sense, this is its return value. And what this is doing in this case is it's returning the pointer to my array as a const pointer to the outside. So I'm trying to prevent them from doing evil, walking all over and past the end of my array because it's const. Can that be hacked? Sure. Am I going to show you how? No. Okay. It's fairly easy to do, but you don't want to do it. Doesn't make sense. Size function and flush. So now, notice that the size of this string object is the size of that pointer plus the size of these two ints. That's the size that if I apply size of, that's the size I'm going to report. That's what's stored in the array. Because the character points to something on the heap. Okay. So if I measure with size of, if I measure the size of a string with 2 characters and compare it to the size of a string with 50,000 characters, I'd see they're the same size. We're not talking about logical size, we're talking about physical size. And that's what's important for storing in an array. That's why we can store strings in an array. So if you want an object that has variable contents to be stored in an array, you have to put those variable contents on the heap. Yeah, that makes sense. Yeah, cool. And flush empties the string. Guess what it does? It changes len to 0 and it puts a terminating null in array of 0. That's all it does. Doesn't monkey with any of the characters. Doesn't. Well, why would it? You know, when you create the default, that's what the default does. You know, you got space for 10 characters, a terminating null, and garbage. Just some nonsense garbage, but you'll never see it because you'll stop at that terminating null. Okay. Cool. Now comes the meat. Finally, we're going to talk about something. So we're going to talk about something really important now. And somebody from the back row says, finally. Okay. I need to go escape, and now I need to go to the next one. So, can you guys in the back row read all that? Can I not make it bigger? Okay, as long as you can read it. If anybody can't read it, I'll make it bigger, but it makes it a little more clumsy for me to go through these. So I'm going to build a default constructor, a constructor that can be called with no arguments, but it also is a size constructor because I have a default value for n of 10. So that means if I call it with no arguments, I'll get a string that has the capacity to hold 10 characters. It's actually 9 characters, if I remember the way this constructor works. I think it sets max to 10 and len to 0. So, but anyway, and here's how I implement it. So string, should be uppercase. So PowerPoint knows that anything after a colon should be lowercase. And so it just makes everything after the colon lowercase. And I've gone through this several times and made all those uppercase. And if I make any change on the page, guess what? Boom, they all go back to lowercase. Because PowerPoint knows that's what should be done. Thank you, Microsoft. But anyway, so understand that, don't get confused. This should be uppercase str. So what's going on here is this is in the class declaration. This is in the implementation file. And just because I named it str, the compiler doesn't know it belongs to this class. It could be a function called str that is a global function or whatever. So I have to preface it by string : to tell the compiler, yes, this belongs to the string class. You know, I can put it inline and then I don't have to do that. If I implement it in the class declaration, which I don't think you should do most of the time, I don't qualify it with this because it's always already qualified by being in the class inside the class declaration. But as long as the implementation is not inside the class declaration, then I need to qualify it with it. Even if it's in the header file. This might be an inline function that I defined in the header file. I still have to preface it with str. And now, notice what happens. Now, my data members are array, max, and len. That's all there are. This is called an initialization sequence, and it only applies to constructors. For constructors, what this does is this takes the array pointer and puts the pointer returned by new of char n in array. This puts n into max and 0 into len. I am really calling constructors. You know, for the primitives, it's just whatever the primitive construction mechanism is built into the code. But for if I had a data member of some other class, then I'm calling. Those are constructor calls. And if you don't use an initialization sequence, the compiler will always construct every single base and data member in your class. Always. Language guarantees that that will happen. And if you don't specify which one you want, it makes a choice, and it may not be the choice you want. So I'm telling it, you know, here's how I want those initialized. And now I simply put the terminating null in the 0 spot, and I don't care what junk is beyond it, because I'll never look at it until I copy characters into it. And here's how I use it. String s creates a default object. This calls the constructor with no arguments. So here, you know, I get n. I'm not passing any integer in there, so I get n, capacity of n. This is creating 5 default strings in an array of 5, big enough to hold 5 strings. And this is calling this function to create a string instance on the heap. Okay. Cool, 5 different ways to call a constructor. 3 different ways to call a constructor. That can drive you nuts when you're first learning C++. You know, the fact that there are a bunch of different ways to call these, and the right way to call it depends on the context. And when you're a newbie, you're always making the wrong choice. Okay, so. But that, you know, that won't happen long. Okay, let me get rid of this. How do I turn this pointer off? Good. Okay, so copy constructor. So purpose is to build an object which is a logical copy of another. There's no physical copy. Well, there's physically things being copied, but there's no, you know, you're not pointing 2 pointers to the same thing. Okay, you're going to make a separate, unique object. So it's declared this way, and again, this should be a capital S. It's declared this way. And here's how you do it. So string of S is array of new char of S dot max. I'm going to give myself the same capacity that the source had. Max is S dot max, len is S dot len. I'm going to count my characters the same as the source. And then for I equals 0, I less than or equal to len, I plus plus array sub I equal S dot array sub I. What happened to the null pointer, the null terminator? Wei Heng, what happened to the null terminator? Usually we say less than. So when I say 0 to less than or equal, I'm copying one more than the number of characters in my array, meaning I'm going to copy that null terminator. So instead of I less than n, and then separately saying array of n plus 1 equals the null terminator, I just copy them over instead of saying array of n. Okay, now string S2 equals S1. No assignment. Copy construction. I'm going to try to trap you on the midterm. I will. A third of you will get it wrong. What's your name in the blue coat with a furry collar? Yeah. Vishal. So, Vishal, are you going to get it right? Don't. Wrong answer. Here's the right answer. Yes! Okay? That's the right answer. Okay. And this is equivalent. It does exactly the same thing. These do exactly the same things. Here, I am allocating this array by making a copy of S1 into the 0th element of the array and a copy of S2 into the first element of the array, into the 1th element of the array. Okay? Cool. And here, I am creating a copy of S1 on the heap in my new object that's pointed to by S pointer. And here, when I call my fun by value, there's no reference symbol here. I'm making a copy of S onto my stack frame. Right? Is that clear? You don't look like it's too clear.
Yeah, I was just thinking, like, instead of doing string S2 equals S1, can we, like, do string S2 is equal to S2 parentheses S1?
You can, these two are equivalent. You can use either one, doesn't matter. They generate exactly the same code. This is traditional to write them this way. So you want to make sure that you get comfortable with that, because most of the C++ code you look at that you didn't write, it'll be done this way.
They copy it to the heap, not to the...
No. This is just making a copy of the string. So what it's doing is, we'll see as soon as I talk about this, okay, it's making, well, right here. So what did it do? It made a copy of max into my max, probably in static memory. It made a copy of len into my len, probably in static memory. It made a copy of, it made a new array and copied the source's characters into my new array. So this is on the heap because I said new. These are in stack memory or wherever that object is stored. Okay? Make sense? Does that make sense to you, young lady?
Yep.
Good. What's your name?
Jessica?
Jessica.
Yep.
You won't let me use your Chinese name. I don't blame you. We always mangle Chinese names, don't we? So, are you born in China or were you born here?
China.
Ah, okay. So, what's your name in Chinese?
Zhang Xu.
Zhang.
Yep, pretty good.
I got that for the next 2 seconds, and then I'll forget. I try to use it, it's your name. I try to use them, but, So That's copy construction. Now let's look at move construction. Nope, I'm going to look at, I'm sorry. Copy constructor, move. Here, move constructor, I just jumped over it accidentally. So here's move construction. So look at what happens here. To build an object, stealing the resources of a temporary, used when movable objects are returned by value. If no construct, movable almost always means they're temporary. And I'll tell you when it's not in a minute. If no move constructor is defined by the class, it will fall back to copy. So it will always do a correct operation. It'll just do it faster if you provide it in your class a move operator. But if it's a temporary and you didn't define a move operator, it won't try to jiggery-pokery some complicated thing that doesn't work. It'll just fall back to the copy constructor you defined. If no move constructor is defined by the class, it'll fall back to copy. And I make some statements about when the compiler will generate. The compiler will generate these, and it's a little more complicated than this, but if you haven't defined any constructors in your class and you don't have any pointers in your class, the compiler will do, the compiler generated move constructor will simply go move each of your bases and then move each of your data members. So in copy, let's go back and look at copy construction again for a minute because I forgot to say that. For the copy constructor, the compiler will always generate a copy constructor if you didn't define it, which does member-wise copying on your bases and on your data members. If your bases and data members have correct copy, assignment, and destruction semantics, you don't supply those operations. You shouldn't. The compiler will generate correct operations because the things that it's copying all provide the compiler the operations it needs. So if you have just primitive data and maybe you've included some containers out of the STL, they all have correct copy, assignment, and destruction semantics. You don't have to write any of those operators, and you shouldn't. But if you're like string that has a pointer, you have to. And you got to write all of them. You don't have to write the moves, but you have to write copy. You have to write copy construction, copy assignment, and destruction if you've got a pointer. Okay. So let's go back to the move construction now. So move construction is going to steal the resources of the source. So what does that mean? So here we are, str string ampersand, so universal reference of s. This is saying no const, because I'm going to trash s. So what do I mean by that? Here's string, blah, array, I'm going to steal his pointer. I'm not copying any characters. I'm copying his pointer. I stole his pointer. I copy his max, I copy his len, and I set his pointer to null pointer. I must do this. If I don't set his pointer to null pointer, we've got two instances pointing to the same object. One goes out of scope and deletes it, and the other one is sitting there pointing to invalid memory and will throw an exception when it goes out of scope. So you must set that to null pointer. Or do whatever you need to do so that that other object can be successfully destructed. Now, typically where we write move constructors is when we point to the resources with a single pointer. That makes it easy. Now, suppose I have some complicated data structure that I want to build. That has maybe a tree. It's got pointers all over the place. Blah, 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 blah. I don't want to write a move constructor that has to walk that tree and do all that ugly stuff. What I will do is I will build that tree on the heap. I'll have a single pointer to the root of the tree, and that's what I steal. And as long as my code is in the same process, they have access, anything. Anywhere in the process, you have access to the same heap in C++, same heap. Can't do this into another process. You can't move something from one process to another other than by serializing it and stuff like that. But see how easy it is? I stole it. I'm a thief. I reached into his pocket and I quickly grabbed his pointer. Okay. If I was in one of the Arab countries, they'd cut off my right hand. That happened in the old days, right? If you were caught being a thief, you'd lose your right hand for reasons we won't go into. So, and here's where it get called. So here, string test function, I've created a temporary string right in here, and when I return it, it's going to call the move constructor. Now, if I don't have a move constructor, it copies it out. But if I have a move constructor, the compiler says, I know that's temporary, because I am leaving that scope. When I return, I'm leaving that scope, and this was declared in the scope, so it's got to be temporary. So always call. Now, I can force that call. Why didn't I show you here? I can force that call by saying, I'll show you in the, let me wait, and I'll show you that in the move assignment. So bear with me, I'll show you that, what I was going to talk about in the move assignment. Pretty sure I have it there. Okay, the promotion constructor is fairly straightforward. So here, now I've declared this explicit, and we'll see what that means down here. But, so I want to coerce an object of another class to one of this class. I want to take some different type and somehow create a type, a string type out of that information. And somehow is determined by what you write here in this code. So I declare it as explicit string const char star. And I don't have to have explicit. If I don't have it explicit, some operations will occur implicitly, and I'll show you exactly what in just a minute. So here's how I write it. So string len static cast of int string len of s. So s is just a literal string, so I got to use the C-style string functions on it to measure its length. I can't ask it what its size is because it doesn't know what its size is. It's just a set of an array of characters, null terminated characters. So I use the string len function, okay, and now max equals len plus 1, array equals new char of len plus 1, len is the number of characters, and one more for the terminating null, and then I copy them over. Piece of cake. We know how to do that. So now, here, when I say strs equals, I have to say, if I want to use a quoted string on the right, I have to say string. So the standard string class isn't explicit. So it will silently let you promote a literal string into a standard string. But my class is forcing you to be explicit about it, okay? Mostly just to show you how that works. And now, if I want to create an array of these, an array of 2 elements, I got to be explicit in both those calls, okay? And you know, so everywhere I use it, I got to be explicit. The design community is kind of vectoring around to the issue is that silent conversions, promotions, and casts can be a source of real problems. You have a type mismatch, and the compiler did something that, you know, did a conversion. You know, use your operator to do the conversion you said, but you didn't want that conversion to happen here. But it silently happened. So with explicit, you have to say, that's what I want. And if you don't say that's what I want, it'll fail to compile. Okay. Destructor. Returns, deallocates resources when your object goes out of scope or when you call delete on it if it's stored on the heap. And here's how you write it. String of, tilde string, the tilde always means if this is the name of the class, it's a destructor. Delete angle brackets of array. If you knew with angle brackets, you should delete with angle brackets. The standard expects you to do that. It turns out that the Visual Studio compiler will work if you leave them off in the destructor, but don't do that. The standard doesn't specify that, and G++ or Clang may not do that. What they do, I don't know. Always delete with brackets. The compiler implementation is absolutely free. If you don't put the brackets, it's absolutely free to call the destructor on the first element of that array and not on any of the others. Because that's what you asked it to do. When you said delete that pointer, if you don't have brackets, the compiler is saying you're asking me to delete that one thing. That's what you're asking it to. And so it's allowed to do that. So a Visual Studio compiler deletes the whole array, keeps track of the fact that this was an array, but I'm not sure that's a good idea, because it encourages you to do sloppy things that might not work with some other standard conforming compiler. So, and almost never do we explicitly call the destructor ourselves, but when we allocate something on the heap, when we call delete, that destructor is called. When an object of our class goes out of scope, when the thread of execution leaves the scope in which the object was declared, the destructor is called. Language guarantees that, always, never fails. You can bet your life on it. Never fails. The language guarantees that a constructor will be called when you declare an object, and guarantees that a destructor will be called when it goes out of scope. End of story. And that's a very elegant resource management mechanism. I like it a whole lot better than managed heaps. In my opinion, managed heaps are a solution looking for a problem. I've said that before. You'll get, all you Java guys and C#, I'm biased, I am. I'm really biased. I like C#, and I've fiddled a little bit with Java, and I'm sure if I wrote more Java, I'd like it just fine, but I would rather develop with C++ than anything else. If you come to the help session tomorrow morning, you'll see me do some cool things for querying that are really easy with C++, a little harder with C# or Java. Okay. So that's a destructor. Now, copy assignment. So here, an assignment operator always is declared this. A copy assignment is always declared this way, okay, with a reference, returned by reference. And the first statement should be this: if this equals the address of S, return contents of this. Or you could say, if it's not equal to, then just include this, either way. But the purpose of that is, so remember, so if I don't have enough memory for my allocation, suppose I was assigning to myself. And you won't always know that. Sometimes, by some circuitous route through your code, you're passing references around and you're assigning to yourself. You didn't know it, but you are. So the first thing your assignment operator may do is delete the array, because it wants to delete the destinations array and create an array and copy over the stuff from the source. Now, if the source is the destination, we deleted the array and we're going to, whoops, okay, doesn't work. So, if this equals out, so this is a pointer to this object, whichever object you're assigning to. If I say S1 equals S2, this points to the address, this contains the address of S1. All that happens in every member function, every non-static member function. Because you don't have code, all the code for the class that follows each object. You don't have code for this object and code for this object and code for this object. Why would we do that? It's the same code. There's one set of code. So how does that code know which object to operate on? Because when I make that call, silently the compiler passes up the address of the object and puts it in a variable called this. So now I can say, if my address is equal to the address of the source, just return the contents of. Now, notice that I'm returning by reference, and I say contents of this. So I'm returning myself. And the reason is that I may say S1 equals S2 equals S3 equals S4. And to get that chain to work, each one of those equals has to return a reference for me to assign from. So that's why it's written that way. Now, do we have enough space? If we have enough space, why allocate a new array? So if max is greater than or equal to slen plus 1, I got enough space, then len equals s dot len int equals I. For I equals 0, I less than or equal to len, so I'm copying the terminating null. Array sub I equals s dot array, return contents of this, and I'm done. But if it's not, then delete array, array equals new char of max equals s max, whatever s's capacity was, I'm going to make that my capacity because I'm assigning that state. Max is part of my state. I make len equal to s len, and I just copy over the characters and return contents of this. So the only difference between those two is that I am allocating, I'm deleting the array, okay, and allocating a new one of bigger size, big enough to hold the capacity of the source. And I invoke it by saying S2 equals S1, or I could say S2 dot operator equals S1. They're absolutely equivalent. They generate exactly the same code. And this is why we need to return a reference to ourselves, because if I said S2 equals S1 equals S0, then now this becomes the argument for that last operator, and that argument needs an object by reference. And so this guy had darn well better return that object by reference, himself by reference, okay? Does that make sense, Nag? Okay. I say these things and I never know. Lots of people will smile. What is this guy talking about? Okay. If you don't understand, ask. Now, move assignment. We're going to go into thief mode again. So to assign the state values by a temporary object of another by moving, essentially we're transferring ownership of that heap allocation. If no other potentially implicit operation is defined, the compiler will generate one, blah, 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 blah. So here's how I declare it. Universal reference, not a const, because I'm going to trash this object. I'm going to change it. Now I say, here's my assignment operator, and I can't use initialization sequences on assignment. They only work for constructors because they are initializing sequences. Okay, so operator equals, again, check to see if I'm assigning to myself. If I am, go away. I don't need to do anything. Now I say max equal s max, len equal s max. I delete my array and I steal his array. Stole it. But now it's my obligation to set his array to null pointer. The language guarantees that when we call delete on null pointer, nothing bad happens. Nothing happens. So now, when he goes out of scope, it's fine. No errors, no exceptions. Nothing was deleted. The memory wasn't changed at all. When I go out of scope because I stole his array, now my array is going to get deleted by my destructor call. Okay. So, and now return contents of this. And so now S1 equals S2 plus S3. So S2 plus S3 is unnamed. I don't have a name for that sum. So that's an R value. That's a temporary. And the compiler absolutely will call this move constructor when I do that, because I'm assigning this temporary to that L value. Right, Wei Hang? Good. Right, Jessica. I tried to remember. I couldn't remember. Now, this is the thing I was talking about before. There's another way, even if the object is not temporary, I can tell it that it's temporary. So I can say S2 equals standard move of S3. Standard move doesn't move anything. Doesn't move anything. It's changing the type. It's telling the compiler the type of S3 is not an L value, treat it as an R value. And now the compiler, because it's an R value, the compiler is perfectly happy to move it. But now you better promise the compiler, I'm never going to touch that again because it's trashed. So your obligation, if it isn't temporary and you move it, is to never touch it again. So typically you don't want to do that. There's a couple of tiny little situations where you might choose to do that. I have done it once. Okay. But, yes?
Delete operation after deletion again with the array. Delete array of array.
Yeah. So when I start this move operation, I have an array and he has an array. I want to replace my array with his array. If I just copied it over, I'd have a memory leak.
But if you are deleting the array, so it means complete memory will swap or only content of it will be.
What that means is that that memory is marked as free. Nothing is moved. It marks that memory as free, and now the next time the heap manager, the memory manager for the heap, needs allocation, it's perfectly free to use part of that memory, part or all of that memory. Okay?
But that memory is still pointed to array object.
It's not const because I don't want this to be const, because I'm going to change it in my class. My class is going to do operations on that array. I don't want to make it const. I'm not passing this out to the public. I'm just binding my private pointer to an array to the sources array. And I have to delete my prior array so that I don't have a resource leak. Okay? Is that clear?
For example, if you want to use operator equals, we have to call out the entire operator equals function or just use equals?
So here, I could have said S1 dot operator equal of S2 plus S3. That would be absolutely equivalent to this. Almost always we use the algebraic form, but I could use the operator form if I wanted to. I show you the operator form so that you can understand why I have to return the contents of this by reference so that I can chain those operations. This would work just fine. If I never changed it, returning void would work just fine. But if I chain them, that won't work. Yeah?
If the assignment operator contains a copy operator and or a default operator, will the first line of invocation be called by the move assignment operator?
So here, what happens, the first thing that when this is called, nothing else happens, just this function executes.
So if the S1 equals to S2 plus...
So here, what happens is nothing changes. I just return a reference to myself. I'm not changing anything. Nothing has changed.
I'm not asking about if this equals to this
Okay.
string. I'm just asking if S2 and so for in the invocation item, if S2 and S3 are all L value. So if they have address, will this
will never be called if they're L values. If I add together two L values, the compiler won't call it.
So in this invocation, in the first line of invocation, the S2 and S3 is guaranteed to be L value, R value.
Yeah, because I don't have a name for it. Here, I said S1 equals S2 plus S3, and there's no name. There's no name for that sum.
S2 and S3 is not a name. They don't have an address.
If it doesn't have a name, it doesn't have an address. You know, it has an address. The compiler has stored it someplace, so it has an address, but only the compiler knows it, and it's not going to tell us.
So in the normal invocation, the S2 and S3 will not be the name, it will be a string or just an array of char.
What happens here, when I do this, the operator plus is called to create a temporary sum. Okay, that's what happens. And I'm going to talk about operator plus on Tuesday. Okay.
So it will return an instant R value of string, right?
Yeah, yeah. So it returns an R value. That's why the move constructor gets called. So it is an R value. That's why the move constructor is called. The move assignment is called. Good question. Okay. Now let me go back. I want to make it really clear. So here's the void constructor, and this says, if and only if no constructors are defined by the class, the compiler will generate a void constructor which does void construction of class bases and members. Just member-wise, it goes to this base and makes a, whatever void constructor is defined for that class is called, same for each of the bases, and then the same for each of the members. And that's correct as long as all of them have correct construction semantics. Okay? So if I've declared any constructor, the compiler will not generate it, and then if I say S1, a capital string S1, semicolon, that'll fail to compile. Okay, because it says there's no void constructor. But if in my class I want to declare a promotion constructor, but I don't need to define copy and assignment and all that other stuff because the semantics is all correct for my bases and members, I can just say I can declare the void constructor equal default. And that tells the compiler it's declared, you can use it, just use your default. Meaning member-wise construction. Language makes a whole lot of sense. Each of its parts makes a whole lot of sense. It's logical, sensible, elegant. The problem is there's so much of it. Okay? And some of it is context dependent. That's the real hard part. Now, so this is context dependent. If and only if no constructors are defined. Declared, actually. If I said defined, I should say declared, because even if I just declared them, it compiler won't. Actually, if I declared them and created an instance of the class, they'd have to be defined. So now, that's the void constructor. Copy constructor, the compiler will always generate a copy constructor. And the copy constructor does member-wise copy of your bases and your data members, member types. And if that's correct, you don't need to supply it. If it isn't correct, you need to supply it or prevent it. I can say, I can declare the copy constructor equals delete, and that says you can't copy this class. There are some data, some elements that it can't be copied, like some of the, I think a critical section can't be copied. So if you hold the critical section, you gotta delete the copy constructor for your class because it can't be copied. Or you can write one that but doesn't keep that critical, but probably the semantics will be funny, and people, that'll be a source of error. So making it a delete is a good idea. So that's the string copy constructor. The compiler will, copy constructor. The compiler will define a move constructor. Essentially, if you haven't defined any, it'll do a default move, which simply calls move on each of the bases and move on each of the members. Okay? That is, it calls the bases move constructor for each of the bases, and then the data members move constructor for each of them. And if one of them doesn't provide a move constructor, it falls back to the copy constructor. So it's always safe, and it'll be as fast as it can be given what's built into the classes you're using. And the STL, all the containers have move constructors. So that's cool. Things can be very efficient. So that promotion constructor will never generate a promotion constructor for you. It doesn't know how. Destructor will always generate one if you don't find it. Does member-wise destruction, and it may not be the right thing. If you have a pointer, it won't call delete on your pointer. The pointer might not point to the heap. It might point to some, it might be a weak pointer pointing to some other object on stack memory, and if I call delete on that, bam! Memory access violation. So it won't. So if you have a pointer in your class, you gotta define your own destructor. If you have a pointer in your class, you gotta define the whole bunch. There's something called the rule of threes. If all of your bases and all of your members have correct copy, assignment, and destruction and move semantics, the compiler will generate all of those. And you shouldn't supply them. You'll get in its way. You can't make bugs. You won't have any bugs in code you didn't write. If that's not true, now you have a decision. You can either implement all of those operations, or you can implement, you must implement void construction, copy construction, assignment, and destruction. You don't have to design the move operations if you don't want to. That's just an optimization. But you must either supply them or you must mark those operations as delete. Meaning, if you write code that invokes those operations, it'll fail to compile. So, threes, construction, assignment, destruction. Threes either allow the compiler to generate them if the semantics are correct for all the parts, or you provide them, or you mark them as delete. Three cases, three things you got to do. Three choices. Okay, I'm going to stop here. My time has run out. So on Tuesday, you will get the second most important lecture, or maybe the first most important lecture of the semester. And tomorrow morning in this room, we'll have a help session. I'm going to talk, when you leave your session, you'll have a really good idea how to design the query. One good way of designing the query mechanism. You don't have to do it that way, but you'll understand how it can be done. And the first session starts at 9. And when the room fills, you're not allowed to bring a chair from someplace else. You are not allowed. Nikhil's going to be here a little before 9. He's going to be checking. Anybody brings a chair through, he's going to have a taser and he's going to tase you. Okay? Or something. Okay? If there isn't room, then come at 10:30. If everybody waits to 10:30, the room may fill up, and you come at 10:30 and I won't let you in because the room is full. So your default should be come at 9, and then if it's overflowed, then come back at 10:30. Okay, see you all. Let's make room for the next class. Let me pack up because there's another class that needs to come in. As soon as I'm packed up, we can talk on the way. Okay. Okay.
不了 object， 所以它跟我上一个 object。好。
I have all my stuff. Thanks, sir.